is a session that came from the South Coast user group that we held on the 5th of May 2026. Firstly, I'd like to introduce your presenters today. You've got myself, Luke Smith, and Robin Pemberton. Just a little bit of background to ourselves, to make you know that we're all human. I'm a father of 3 boys and have a cat. I enjoy snowboarding and mountain biking. I'm the co-founder and technical director at ElysianIT. And I guess from a coding perspective, I'd probably call myself a bit of a script kiddie. Robin, over to you.
Yeah, and so I'm the father of 3 girls and the proud owner of a dog. And I like sailing boats and fighting. God, that sounds a bit extreme. I like martial arts. That's a simpler way of putting it. I'm the practice lead for ElysianIT, and I would now describe myself as an AI meat puppet.
The reason we started on that journey is that we had been approached by a number of different organizations, from internal legal departments to legal firms, whereby they were struggling with undertaking legislation research. They sort of found that some of the tools they were using was quite expensive, or they didn't have any tools. They were just using general internet searching to go and find out if certain legislations and rules are valid or where they may have been updated. Ultimately, they sort of found that they were having to switch between multiple windows, and it wasn't within the tooling that they used on a day-to-day basis. And for those companies we've been talking to, they were mainly sat within the Microsoft Office suite and predominantly within Word. And that sort of brought us to the solution that we came up with, which was our Law Copilot. From an architectural perspective, what we seek to build were a number of different components. We have an Office add-in, which is rendered within the Office tooling, and we'll demonstrate that shortly to you. The way that the add-in gets rendered out is through a web application using TypeScript, and that's hosted on Azure Web App. That web app, once it takes some user input, needs to go off and actually query certain data sources, and we administer that with some middleware that is hosted on Azure Functions. And the Azure Functions goes off and calls into Azure Foundry, as well as the legal legislation API called Lex. And we're going to dive into those in a little bit more detail as we go through the demonstration. What I'm going to do now is hand over to Robin to talk through those various components, and then how we went about generating the code through Visual Studio. Over to yourself, Robin.
So from the front end perspective, we see we've got a Word document here, which is a dummy contract of employment. It has a number of terms within that contract, and you can see up here in the tool panel, we've got our legal research assistant. So if I was to select this button, you'll see an add-in panel fly out from the right hand side, and I have the ability to be able to pick up a particular piece of text within our document, and having done that, you'll see that that becomes the piece of selected text that we're going to work on, and then we can choose a particular research action that we want to fulfill. So in this case, what we're going to do is we're going to request a legal definition of the term TUPE. So the tool will take the selected text, pass it off to our back end, and as you can see, it's been able to produce a definition for that term. And then it's provided a list of the sources that it searched in order to be able to present us with that particular term. And then in terms of the result sets that it's come back with, it's then highlighted a particular one of those results as being its recommended source of information for that particular term. I can then use that recommended definition and insert a citation for it, and I can also inject a summary for that term. So that's the front end, and in terms of what's happening on the back end, in the first instance, when the task pane loads, there's this use selected text hook that mounts, and there's a use effect which will run as it loads, and it takes the piece of selected text that you've provided, but it will also mount this document selection changed event, so that subsequently, if another piece of text is selected, the text is picked up and it's presented within that panel. So that then appears within this task pane piece of code that we've got. So from there, we've also got this action selector control, which is the drop down panel that you saw appear. And there's a rule in there that says that the drop down won't appear until the user's actually selected a piece of text. But this is the selection text control, which is mounted inside that panel. And then once the user's selected a particular piece of text and it's mounted inside of that task pane, which is in here, the handle selection event that you can see executes this function, which is to perform the search. It takes the selected text that you've provided and it takes the action that you've selected. So in our case, it was to get a definition, and then passes that off to this class here, and it calls our perform search action. So perform search then looks at the action type, and in our case, our research action that we passed was the get definition function, and the get definition function then gets passed to our API service, which is where we've wrapped the calls out to our Azure function backend. And from here, those call out to our function app. So this is our legal API Azure function backend. And then from here, we're executing our get definition method, and this will execute, take the particular piece of text that we've supplied, and in the first instance, it makes a call to the Lex API and executes a search for the given piece of text. And there's a semantic search engine on the back end of the Lex API that will return to us a record set of sources that are relevant to that particular search term. So from this point, we take those the returned set of results, and we then implement this score source function, which is executed internally within our application to rank the result sets that have the result set that has come back according to a given set of criteria. So in our case, we downgrade things that relate to Scottish legislation and the Scottish Parliament, Northern Ireland instruments, and we rank things which are statutory instruments that relate to the UK Public General Acts, and we use that to force the ranking of the results that we've got. Because what we found was when we pushed it out to, originally we would take the source data set and we'd pass that out to the OpenAI backend and ask it to rank them according to what it thought was most relevant. And no matter how we structured the base prompt that we were sending to OpenAI, it would always rank Scottish legislation higher than UK's legislation. So as I say, we retrieve a data set, we augment that with some ranking, and then we take that whole packet of information and we pass that off to OpenAI down here. So this is the point at which you can see we've got a prompt which we're passing to that back end and asking it to give us a definition of this particular piece of text. And you can see within the scope of the call that we're making, we limit the number of tokens that are coming back in the response to reduce cost and to speed up the time that it takes for it to respond to us. And then we also limit the temperature of the query that we're making, so that it's not creative about the response that we're bringing back. So having done that, we get our response text back. We confirm that it's a JSON packet and that we've got some results contained within that data set. And here, if we don't have a result, we just send back the response text that we received from the original request back to out to the Lex API component. And that's the full end-to-end process of taking the piece of text from the front end, passing it back through our React static web application on the front end, executing the call to the Lex API to get the sources. We then rank the sources according to our rules, and then pass that off to the OpenAI to get our definition, and then pass that back to the front end. So it's an example of a RAG pipeline, so Retrieval Augmented Generation. As you can see here, I've got an empty project in this instance, and I've got a Claude Markdown file, which as you can see is a detailed description of the project that we're about to build. So it describes the technology stack that we're going to use, describes the environment variables that we're going to provide. It describes the function patterns. It lists out the endpoints to the Lex API component. It describes the scoring algorithm that we're going to implement, and how citation formatting should be done, and it describes what that word add-in component looks like on the front end, and that's context which we'll use to ground the whole process of executing the Claude code agent, so that if the context window that we're in is closed for some reason, or we move away from that window, the coding agent is able to understand the structure of the project that we're working in, and how it should go about doing that. So in terms of actually executing that process, you can see here on the right hand side I've got my code agent loaded, and currently it's set to automatically edit. Now I can set this into planning mode, and this is much like you would do in the real world. If you had physical developers, you'd give them some product definition, and you'd ask them to plan how it was they were going to go about building a solution to deliver that product. It's no different in this world. You provide a prompt and you ask the agent to build you a plan, and so at this point I'll execute that, and you'll see the agent is going off, and it's reading through the markdown file, which is the explanation of what we want built, and it's then going to build a plan which we can then look at and modify if we need to, and then it will and then we'll ask it to execute that plan in phases.
Thank you for that, Robin. I think people will find that really valuable in the way that you've managed to put together a design through markup that can then be used through Claude, GitHub, Copilot, Gemini, or other AI solutions to actually help you to build those building blocks and with the relevant guardrails that are in place. And I guess just sort of a quick recap of what Robin's gone through there. He's run that, created the markdown that defines his specification. He's asked Claude to consume that with a prompt with some parameters. And what it will then do is produce a plan in the phases that he's defined. And then it will start to ask some questions. Effectively, do you agree with the plan that it's put together and the approach, the relevant runtimes, code snippets, error checking principles? It will then give you that option to either rework it. You might want to suggest an alternative, maybe a different runtime should be used or a different LLM model. Or you can ask it to maybe build out specific phases and components of the project, allowing you to sort of check, review, and maybe adapt different phases or components of the solution rather than a whole product. It will then build out the repositories, it will build out the relevant files, and those are the files which Robin has walked through today. So it really helps to, once you put the groundwork in at the beginning to define the architectural components and the design, would then start to help to accelerate the end project. Now, the first piece that comes out of it isn't necessarily the right solution, is it, Robin? It tends to need an iterative process. It tends to need some form of review to be able to finalize what that solution looks like at the end.
Yeah, I mean, there's certainly in respect of that, you would likely get a product in the first instance that may not work or might be close to something that's what you require, but you need to work with the agent, and in some instances you might need to just go and modify the code yourself in order to get a working solution.
Brilliant, thank you for that, Robin. As you know, some of the learnings from our side, and you've probably heard some of these as Robin's gone through the demonstration, but it's worth highlighting some deployment tips. We put these into various sections depending upon the different components, but from an Office add-in, Word add-in perspective, Office will require you to have certificates on the application that's being used to render out the bar. So one of the gotchas is to make sure that you have the SSL certificate on it, because it will refuse HTTP connections. The second one is allowing the cross-scripting to occur and posting the origin header. Otherwise, what will happen is it will be rejected as the code is executed. So CORS is key to have enabled and targeting the correct URLs. When it comes to Azure Functions, it's worth making sure that the runtimes align. Sometimes the runtime that's in your local stack may be the different version to what's within Azure, and aligning those will be key to make sure that the testing and the running of the solution will run as expected. One of the lessons learned from running cost perspective is to consume using consumption plans. Consumption plans is on a pay-as-you-go model for the transactions that you're consuming. Starting off on consumption allows you to then look at if premium starts to become a more cost-effective solution. So go with consumption plans first and then look at using premium plans. The next one is to make sure you enable keep alive agents. That just makes sure that the calls don't time out and it can continue to communicate through to the end of the request. And then from a AI perspective, there are some elements in here, one specifically called temperature. Temperature controls creativity. Being that we want to make sure that it only returns back the source of truth, we want to make sure we turn down AI's creativity to the lowest level so it returns back the actual information rather than it trying to be creative and change what that output might look like. It's worth noting that utilizing Azure Foundry, or what it was called before, Azure AI Foundry, defining it has built-in guardrails, built-in filtering, and in some instances they may need to be tweaked because maybe some of the result sets that you are returning that has content filtering because it might be down to protected use cases. That filtering may need to be tweaked, but it's worth noting that it's built in to provide a level of protection. And then lastly is around max tokens. So max tokens is the amount of information that is being sent and returned within the learning model. It does affect cost because tokens is a costed component of a response that comes back. The two parts of this: one is the cost, but also the speed of response. So making sure that that is set to an appropriate level is key for a costly but also responsive solution. And that sort of ends our session today on our Legal Copilot. But it's worth noting here at ElysianIT, we work and build a number of different solutions across multiple sectors. We're a Microsoft partner, Microsoft service provider, and we're on the G-Cloud frameworks from a government procurement process, and we hold a number of security certifications from Cyber Essentials Plus to CREST Pathway member to ISO 27001. From our services capabilities, we like to look at this in three key service areas. We have our managed services and security operations team. We have our implementation and migration services, and our data, AI and application innovation, which is where today's session has come from. Fundamentally related to the Microsoft product suites, but as a system integrator, we also work with a number of third-party solutions, be them security-based, be them ERP, business systems, or other multi-cloud platforms. Once again, thank you for joining us today on this session, and look forward to any comments or any specific requests. Then please visit our website, ElysianIT.com. Take care all. Bye now.